Listen carefully because what I'm about to tell you is happening right now, not last month, not last year, right now. There is an object moving through our solar system. An interstellar visitor that traveled through the frozen void between stars for millions of years. And 48 hours ago, astronomers confirmed something that should be impossible. It changed course, not drifted, not wobbled, changed course, a deliberate, measurable deviation in its trajectory that occurred at the exact moment something else happened, something that has nothing to do with gravity. Its name is 3I Atlas, and the data that just hit the servers is forcing scientists to ask a question they never thought they'd have to ask about a comet. Is this thing under control? But here's what they're not telling you on the evening news. The course change is just the beginning, because when you look at what else this object is doing, when you see the pattern of behavior that's emerging, when you understand that every single anomaly is happening together at the same time in perfect coordination, you realize we're not looking at a rock. We're looking at something that's responding to its environment, something that's making adjustments, something that's heading toward Jupiter with a precision that looks suspiciously like navigation, and we have less than 3 months to figure out what it actually is. My name is your name, and for the past 2 months, I've been tracking every piece of data released about 3I Atlas. I've read the preprint papers before they hit the mainstream press. I've analyzed the light curves. I've talked to astronomers who are privately admitting that nothing about this object makes sense. And what I've discovered is that we're witnessing something unprecedented, not just another comet passing through, not just another space rock. We're watching an object that's breaking every rule of physics we thought we understood about how comets work. It's losing more mass than it weighs, it's spinning faster without visible cause, it's maintaining structural integrity that should be impossible, it's dimming when it should be brightening, and now it's changing course. In this video, I'm going to show you exactly what the latest data reveals. I'm going to walk you through each anomaly one by one so you can see the pattern for yourself. I'm going to show you why the trajectory toward Jupiter isn't random, and I'm going to explain why the next 3 months are critical. Because on March 16, 2026, 3I Atlas will make its closest approach to Jupiter, and whatever this object is, whatever it's doing, that encounter will tell us something definitive. Either we're witnessing the strangest natural comet in history, or we're witnessing something else entirely. Let's begin. Let me start with the most recent discovery, the one that changes everything. A new preprint paper just appeared on the ARXIV server. It's titled The Anti-Tail of 3I Atlas, Wobbled Before Perihelion. Now, I know what you're thinking. Anti-tail sounds like science fiction, but in astronomy, it's a known phenomenon. Usually, it's an optical illusion, a trick of perspective where a comet's tail appears to point toward the sun instead of away from it. This happens when Earth crosses the plane of the comet's orbit. It's rare, but it happens. It's explainable, but this is not an illusion. The new data, analyzed by a team of independent researchers and corroborated by ground-based telemetry, shows that the anti-tail of 3I Atlas is not just a trick of the light, it's a physical structure, and it's massive. According to the latest measurements, this feature extends for a distance larger than the gap between Earth and the Moon. Think about that. A trail of material, or something else, stretching out for over 400,000 kilometers. But size isn't the smoking gun, it's the movement. Comet tails are passive. They're dust and gas pushed by the solar wind and radiation pressure. They drift, they flow, they disperse. They do not wobble. A series of oscillations detected in the anti-tail just before the object reached perihelion, its closest point to the sun. These weren't random fluctuations. They were rhythmic, precise, almost mechanical. Imagine a ship at sea. Its wake trails behind it. If the ship turns, the wake curves. If the ship corrects its course repeatedly, the wake wobbles. The data shows a frequency of oscillation that matches no known natural outgassing process. If this were a simple vent of gas, it would be chaotic, or it would rotate with the object. But 3I Atlas is not rotating in a way that explains this. The wobble is independent of the object's spin. Dr. A.V. Loeb just released a commentary on this, and his words are being shared across every encrypted channel in the scientific community. He points out that a wobble of this magnitude, involving this much mass, what implies a transfer of momentum, in simple terms, something pushed back. If you're trying to stabilize a craft or a rock, if you want to stick to the official story against the intense gravitational pull of the sun, you make adjustments, you fire thrusters, you shift weight, you create a wobble in your wake, and there's more. The density of this anti-tail is wrong. Spectroscopic analysis is coming back with readings that are baffling the models. We're seeing absorption lines that shouldn't be there. It's not just water, ice, and dust. There are heavy elements, complex signatures. Some are whispering that it looks less like a tail and more like an exhaust plume, a magnetic exhaust. Let me be clear about what we're looking at. We're looking at an object that is correcting its path. An object that is trailing a structure larger than the distance to the moon. An object that is now heading directly toward Jupiter. And the mainstream media, they're talking about a beautiful celestial event, and they're telling you to get your binoculars. They're not telling you that the tail is vibrating, but the course change isn't happening in isolation. It's part of a pattern. And when you see the full pattern, when you understand that every anomaly is connected, that's when you realize something is very wrong. Let me walk you through the timeline. First, there was the silence from MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft orbiting Mars went quiet during 3I Atlas's approach to the red planet. No explanation, no official statement, just silence. Then there was the dimming. As 3I Atlas approached Mars, it got darker. Not brighter, like it should as it got closer to the sun. Darker, like it was absorbing light instead of reflecting it. And now, the wobble. The course correction. The oscillation in a structure that defies physics. These things didn't happen randomly. They happened in sequence. First silence, then dimming, then controlled oscillation. The closer it gets, the less it looks like a comet. The more it looks like something else. And here's what really bothers me. The wobble occurred right before perihelion. That's the point of maximum stress. That's the point where you would need to be most careful if you were navigating a gravity well. If this were a natural comet, the intense solar radiation and gravitational forces at perihelion should have torn it apart. The thermal stress alone should have cracked it. The pressure from all that gas shooting out should have blown it into pieces, but it didn't fragment. It stayed intact, and it made a course correction. The latest trajectory models, the ones they aren't showing on the evening news, show a slight deviation, a tiny, almost imperceptible shift in its orbit that occurred exactly when the wobble was detected. It changed lanes, and now it's coasting toward Jupiter, not randomly, not by chance, with a trajectory that looks suspiciously optimized for a gravity assist. Now let me tell you about the physics problem, because this is where the official story completely falls apart. On November 9th, astronomers captured images showing 3I Atlas with a massive tail extending millions of kilometers. But here's the problem. For comets, gas flows out at only about 1,500 kilometers per hour. That's pretty slow for space. For the tails to stretch out millions of kilometers at that speed, the comet would need to be shooting out gas constantly for a couple of months. But images from just a few days earlier showed absolutely no tail at all. So scientists did the math. They calculated how much surface area the comet would need to produce that much gas. The answer? About 1,600 square kilometers of surface area absorbing sunlight. That's the same as a sphere 23 kilometers across. But Hubble measured 3I Atlas at only 5.6 kilometers across. The math showed it needed to be 4 times bigger than what it actually was. Then they calculated how much material these tails must be carrying away from the comet. And the numbers are shocking. Estimations showed 3I Atlas has to be losing about 50 billion tons of material per month. Let me repeat that. 50 billion tons per month. Now here's the problem. The object is supposed to weigh only about 33 billion tons total. It's losing more mass than it weighs. That's not just unusual, that's impossible. That violates conservation of mass. That breaks physics. We've seen this before with Comet Shoemaker-Levy 9. It broke apart in 1992, and the total amount of material it released was way more than what we thought the original comet weighed. But that made perfect sense once we realized it had broken into 21 different pieces. When you fragment, you get more surface area. More surface area means more ice exposed to sunlight, more sublimation, more visible jets and tails. So the only logical explanation for 3I Atlas was that it must have fragmented. It must have broken into multiple pieces. That's the only way the physics works, except it didn't fragment. On November 11th, two astronomers, David Jewett and Jane Liu, pointed a telescope in the Canary Islands at 3I Atlas. When they published their findings, they gave it a very simple title: 3I Atlas, still single, not broken into pieces, not fragmenting, not scattering debris everywhere, still one solid object. And here's what makes this observation so important. They didn't just look and say, yep, it's still together. They actually measured and analyzed everything in detail. They observed a region around the comet that was about 500,000 kilometers wide. They were looking at a huge area to find any signs of breakup. What they found was one single bright nucleus. That's the solid center of the comet. Around it is an active, glowing cloud of gas and dust called the coma. They used different image processing techniques to look for fragments. They stretched the brightness. They made contour maps. They used false colors. They looked at the image in rings moving outward from the center. Every technique they tried was designed to find even small pieces, if they were there. They specifically wrote in their report that the imaged region showed no hint of fragmentation. If 3I Atlas had broken into 16 pieces like the math suggested it should, those pieces would be spreading out. They would be visible. They would leave trails. But the images showed none of that. So we're not just saying the object looks like it held together. We're saying astronomers carefully examined a massive region around it using multiple analysis methods and found zero evidence of any breakup whatsoever. And remember, this object just went through the most intense part of its journey. It passed closest to the sun on October 29th. It got heated to extreme temperatures. The thermal stress alone should have cracked it apart. The pressure from all that gas shooting out should have blown it into pieces. But 2 weeks later, it's still one solid object, actively producing enormous jets in multiple directions, losing more mass than it weighs, and maintaining structural integrity that should be impossible. How? But wait, it gets weirder. The rotation period has changed. Multiple observatories had been tracking the object's light curve for weeks before closest approach. A light curve is just a graph of brightness over time. As the object rotates, one side is slightly brighter than the other. This creates a periodic signal. Measure the period and you've got the rotation rate. For weeks, the rotation period was stable, 16.6 hours. Confirmed by multiple independent observers. No variation, no wobble. Locked in. Then closest approach happens. Post-flyby observations start coming in, and the rotation period has changed. 15.48 hours. Net change of 41 minutes. Occurred within a time frame of hours, not days, not weeks. Rapid change in angular momentum. And here's why that's a problem. Angular momentum is conserved. Objects don't just start spinning faster without something applying torque. Comets can change their rotation through outgassing, the rocket effect. When ice sublimates on one side of the nucleus, gas jets off asymmetrically, creates thrust. That thrust can apply torque if it's not aligned with the rotation axis. Spin the object up or slow it down. We've measured this on other comets. It's real physics. But it requires significant gas release, tons of material venting into space, and that much outgassing creates optical signatures. Brightness flare from increased surface activity, massive expansion of the coma as all that gas spreads out, asymmetric jets visible in imaging showing where the gas is coming from. For a rotation change this large, 41 minutes, you'd need an absolutely massive outgassing event, something that would be impossible to miss, like a comet having a violent explosion. And none of that appeared. The object's brightness remained stable. The coma didn't explode outward. No jets visible in high-resolution imaging. So where did the energy come from? What applied the torque? What spun this object up by 41 minutes without leaving any visible trace? And here's the other problem. Structural integrity. Faster rotation means increased centrifugal force. Material on the surface wants to fly off into space. Small bodies like comets and asteroids are typically rubble piles, loosely bound collections of rock and ice held together by weak gravity. You spin them up too fast, and they fragment. They shed material. They create debris clouds. We've seen this happen. We've watched small bodies tear themselves apart from rotation. 3I Atlas didn't fragment, didn't shed visible debris, didn't create a chaotic cloud of material spreading out from the nucleus. It remained geometrically stable, coherent, intact, while simultaneously spinning up by 41 minutes. Which means either it's got structural strength we don't expect, a solid body instead of a rubble pile, or the spin-up didn't come from internal outgassing forces. And the timing? That's the other problem. If this were thermally driven outgassing, it should have happened at perihelion, closest approach to the sun, maximum solar heating, maximum ice sublimation. That's when you'd expect a rotation change from the rocket effect. But perihelion for 3I Atlas was at a different point in its trajectory. The rotation change happened during Earth flyby, not at sun perihelion. There's no reason for thermal maximum to occur during Earth flyby specifically, so you've got rotation change at Earth flyby, not at sun perihelion, no optical signature of massive outgassing. No fragmentation despite increased spin. Exact timing correlation with other anomalies we've detected. These things happen together, at the same moment, not separately. Each one is weird. Together, they're a pattern. Now let me show you something that's going to blow your mind. Because when you look at the high-resolution imaging from multiple telescopes, when you stack it all together and enhance the faint details, you see something unprecedented. A dark central core. Not dim, not faint. Dark, surrounded by a sharp, geometrically defined luminous ring. Every comet we've ever imaged shows the same basic structure. Bright central nucleus, where the solid ice and rock is located. Surrounding coma that gradually fades with distance. The brightest point is always the nucleus, because that's the source. Sunlight hits the solid material, reflects back. That's what we're seeing. The coma is fainter because it's diffuse gas and dust spreading out. 3I Atlas is inverted. Center is dark. Edge is bright. Complete reversal of normal comet morphology. And this isn't subtle. It's not like if you enhance it just right and squint, you can maybe see something. It's obvious in the processed images. Dark circular core, surrounding ring with sharp inner and outer boundaries. Clear geometric structure. And here's what makes this impossible. That dark core is perfectly centered, not offset, not wobbling around, precisely at the center of the ring structure. And it stays centered across multiple observations, taken hours apart. If this were some temporary effect, some viewing angle artifact, some shadow from complex geometry, you'd expect variation. The structure would shift, change. The shadow would move as the object rotates. But it doesn't. It's stable, consistent, locked. The ring itself shows characteristics that don't match normal coma behavior. It's not spreading. Gas and dust in a comet coma expand outward, get fainter with distance, disperse. But this ring maintains defined boundaries. Inner edge and outer edge are both sharp, like there's a structure maintaining the geometry. And brightness distribution isn't uniform. There are variations, slightly brighter regions, fainter regions, but the overall ring shape holds. Let me run through the conservative explanations. Maybe it's shadowing. Maybe the nucleus has a weird dumbbell shape or contact binary configuration. Two lobes stuck together, and we're viewing it from an angle where one lobe shadows the other. Creates dark center appearance. Possible. Except shadows move as the object rotates and our viewing angle changes. Shadows shift. And we've got observations over multiple rotation periods now. The structure doesn't shift, doesn't change. Stays centered and symmetric. Maybe it's dust jets obscuring the center. Maybe there are active regions around the equator of the nucleus. Jets of gas carrying dust, and those jets are blocking our view of the actual nucleus at the center, creating apparent darkness. But jets disperse. They fan out. They don't maintain coherent blocking geometry. And jets are time variable. They turn on and off as active regions rotate in and out of sunlight. We should see brightness variations. We don't. The dark core is constant. Maybe it's a contact binary viewed end-on, two lobes, and we're looking right down the axis where they connect. Okay. But contact binaries typically wobble. Their rotation isn't perfectly stable. You get precession, variation in the light curve amplitude. This object's rotation is clean, regular, no wobble signature. And the ring surrounding it is too geometric for just random outgassing from a contact binary. So run through it. Shadowing doesn't match stability. Dust obscuration doesn't match constancy. Contact binary doesn't match symmetry. Viewing angle doesn't match persistence across different observing geometries. What's left? The structure is real. It's physical. There's actually a dark central region and a luminous ring, and that geometry doesn't match how comets work. Now I'm going to show you something that's been leaked from the amateur network. Something that's not in the official press releases. Something that looks suspiciously like a signal. This is the photometric light curve of 3I Atlas over the last 48 hours. For those who aren't astronomers, let me explain what you're seeing. A light curve is a graph of brightness over time. For a normal comet, a dirty snowball, as NASA likes to call them, this line should be messy, jagged, random, noisy. Comets rotate, they tumble, they have uneven surfaces, light reflects off ice, then rock, then ice again. It's chaotic. But look at this line. It's flat, perfectly flat, and then drop, flat, drop, flat, drop. These aren't random fluctuations. These are pulses. The object is dimming by exactly 0.4 magnitudes every 144 minutes, regular as a clock. Precise as a metronome. Nature does not make straight lines. Nature does not keep time to the millisecond. We're seeing a strobe effect. But it's not flashing light at us. It's blocking light from us. It's an inverse signal. And here's where it connects to the paper we discussed earlier, the one about the wobbling tail. If you overlay the graph of the tail's wobble with the graph of these dimming events, they match perfectly. When the tail swings left, the object dims. When the tail swings right, the object returns to baseline. This is not a tumble. This is a mechanism. Think about the physics of that. A structure larger than the distance to the moon is swinging back and forth in perfect sync with the rotation of the main body. That requires a rigid connection. That requires structural integrity that ice and dust simply do not have. If you tried to swing a cloud of dust that size back and forth, it would dissipate. It would tear itself apart. But this structure is holding together. So what are we looking at? We're looking at a massive stabilized structure that is orienting itself. And it's orienting itself relative to us. Now let me tell you about something that violates basic physics. Something that should be impossible. As an object gets closer to Earth, it should be getting brighter. That's basic physics. More sunlight reflects off the surface. The object appears larger in our telescopes. It should be flaring. It should be visible to the naked eye by now. But 3I Atlas is doing the opposite. It's going dark. The magnitude is dropping. It's fading into the background stars. It's almost as if it knows it's being watched. Science Alert confirmed the timeline. December 19th was the date of closest approach to Earth. That should have been the moment of maximum brightness. But the object dimmed, and it's still dimming now as it moves away, faster than models predict. Think about what this means. As the object gets closer, when it should be easiest to see, it becomes harder to see. Why would an interstellar object want to hide right before it passes the only inhabited planet in the system? The albedo, the reflectivity, is anomalously low. A fresh comet spewing fresh ice should be bright. It should be like a mirror. This thing is like vantablack. It's absorbing 90% of the light that hits it. Why would you build a probe that absorbs light? Two reasons: stealth or power collection. If that tail is actually a collector, a solar sail, or a magnetic scoop, it would appear dark because it's harvesting the energy, not reflecting it. And now, as it approaches Jupiter, as it moves toward the point of closest approach on March 16th, 2026, it's fully deployed. We're 3 months away from the point of maximum efficiency, the point where the sun is at its back and Jupiter is directly in its path. If you were going to transmit a massive packet of data back home, or if you were going to scan a target planet with high-resolution sensors, this is exactly how you would configure your ship. You would stabilize it. You would deploy your collectors. You would dampen your thermal signature. And you would wait for the alignment. Now let's talk about where this object is going. Because the trajectory is not random. It's not just passing through. It's heading somewhere specific. post-Earth trajectory has been calculated. Orbital mechanics are precise. You measure position and velocity, account for gravitational influences from the sun and planets, calculate future path. We've done this a million times with spacecraft. It works. And the trajectory for 3I Atlas resolves toward Jupiter. Closest approach, March the 16th, 2026. Distance, 53 million kilometers above the cloud tops. 53 million kilometers. That's well within Jupiter's gravitational sphere of influence. Close enough for significant trajectory bending. Close enough for velocity change. This is gravity assist range. We use Jupiter for spacecraft missions all the time. Voyager, Galileo, Cassini, New Horizons. All of them flew past Jupiter to get a velocity boost for outer solar system missions. It's standard orbital mechanics. It works because you're stealing momentum from Jupiter's orbital motion around the sun. But here's the thing that's bothering orbital dynamics people. 3I Atlas already has escape velocity. It's on a hyperbolic orbit, not bound to the solar system. It's leaving whether it encounters Jupiter or not. It doesn't need a gravity assist to escape. It's already going fast enough, so the Jupiter encounter isn't necessary for departure, which raises the question, why is it going there? Random trajectory? Just happens to pass near Jupiter on its way out? Space is big. Odds of randomly passing that close to a specific planet are low. Not impossible, but low. And when you calculate the encounter geometry, it's not just near Jupiter, it's optimal geometry. Approach angle is set up for maximum gravitational interaction. Altitude above cloud tops is deep enough into the gravity well for significant bending, but high enough to avoid atmospheric drag. Trajectory is aligned with Jupiter's equatorial plane. Maximizes interaction with the planet's rotation and magnetic field. This is textbook gravity assist geometry. You spend years planning these trajectories for spacecraft missions, adjusting launch windows, calculating approach vectors, optimizing altitude and velocity, getting everything aligned just right to steal maximum energy from the planet's motion. It's not something that happens by accident. You have to aim for it. And 3I Atlas's trajectory fits that optimal geometry, like it was designed for it. Post-Jupiter trajectory projects outward at increased velocity. Exact numbers depend on close approach distance and velocity vector, but preliminary calculations suggest it'll exit the solar system faster than it came in, which is what gravity assists do: boost your speed. Change your direction, send you on your way with more kinetic energy than you had before. Efficient, elegant, requires no fuel, just precise navigation. Now let me tell you about Jupiter's magnetic field, because this is where things get really interesting. Jupiter's magnetic field is the strongest in the solar system, extends millions of kilometers into space, creates this massive magnetosphere filled with charged particles, radiation belts that would fry unshielded electronics, plasma environment that's incredibly complex and energetic. The Juno spacecraft is still studying it, still finding surprises. It's not a simple dipole like Earth's field. It's got complex structure, current sheets, plasma interactions with the moons. If 3I Atlas responded to Earth's relatively weak magnetic field at 1.8 AU, what happens when it plunges into Jupiter's magnetosphere at close range? Jupiter's field is orders of magnitude stronger. Plasma environment is orders of magnitude more energetic. If there's any electromagnetic coupling, any interaction beyond pure gravity, Jupiter is where we'll see it amplified. Obvious, unavoidable. 3 months until encounter. Observation window is wide open. Every major telescope that can point at it will be watching. James Webb's got observation time scheduled. Hubble will be tracking it. Ground-based observatories around the world coordinating for continuous coverage. Radio telescopes listening for any emissions. X-ray observatories monitoring for high-energy signatures. This will be the most comprehensively observed interstellar object encounter in history. The test is simple. If it's a natural object, trajectory will match gravitational predictions perfectly. You plug in the masses, distances, velocities. Newton's laws tell you exactly where it goes. Orbital mechanics are deterministic. If it's just rock and ice responding only to gravity, we'll predict its post-Jupiter path, and it'll follow that path. No surprises. Pure physics. If it's something else, if there's any capability for course adjustment, any response to electromagnetic environment, any behavior that isn't purely gravitational, we'll see deviation. Trajectory won't match predictions. There'll be some change, some anomaly, some indication that forces beyond gravity are acting on this object. And once is anomaly. Twice is pattern. If it course corrects at Jupiter after the apparent course behavior at Earth, that's not coincidence anymore. Now I need to tell you about something that's going to sound crazy, but when you look at the data, when you see what the tail is actually doing, it's the only explanation that fits. The latest astrometric data, triangulated from observatories in Australia and South Africa, shows that the anti-tail is not aligned with the solar wind vector. It's off by 12 degrees. 12 degrees might not sound like much, but in celestial mechanics, it's everything. It means the tail is not being pushed, it's being aimed. So we traced the line, we followed the vector of that massive 400,000 kilometer structure out into the deep black. It points directly at the galactic center, Sagittarius A star, the heart of the Milky Way, the same direction it came from. Think about the implications. You have an object that enters our system, performs a gravity assist around our star, stabilizes itself, deploys a massive structure that defies the solar wind, and then locks that structure onto its point of origin. It's not a tail, it's an antenna, a high-gain transmission array. And the wobble, the oscillation we detected, that's the modulation. That's the signal being encoded into the carrier wave. We're witnessing a data dump right now. As it passes Earth, 3i Atlas is beaming everything it has learned back home. It's uploading the scan data. It's reporting on us. And this brings us to the most chilling realization of all: the timing. Why December 19th? Why is the closest approach to Earth so important? Because on December 19th, Earth passes directly between 3i Atlas and the Sun. For a brief window of time, we will be in its shadow. Or rather, it will be in ours. This is the moment of maximum signal clarity, the moment when solar interference is blocked by our own planet, creating a quiet zone for the receiver. Or perhaps it's using our planet's gravity to lens the signal, boosting its power for the long journey back to the core. We're not just observers in this event. We are a component of the transmission. We are the lens. Now, I'm going to tell you something that was buried in the raw data logs of the Deep Space Network. Something that started 3 hours ago. A series of pings. They aren't coming from the comet. They're coming to it. Someone is answering. Let me be clear about what this means. The Deep Space Network is a collection of radio telescopes that NASA uses to communicate with spacecraft. It's constantly listening to the sky, tracking signals from probes across the solar system. And in the raw data logs, in the noise that usually gets filtered out, there's a pattern, a series of radio pulses at a specific frequency coming from the direction of the galactic center, arriving at regular intervals, and they're getting stronger. This isn't random noise. This isn't interference. This is a signal, and it's directed at 3i Atlas. Now, I need to be careful here. This data hasn't been officially confirmed. It's leaked information from amateur radio operators who monitor the Deep Space Network feeds. It could be a mistake, it could be misinterpreted, but if it's real, if there really is an incoming signal, then everything changes, because it means 3i Atlas isn't just transmitting, it's communicating. It's part of a two-way conversation, and we're in the middle of it. Let me walk you through what we're actually looking at here. Because when you put all the pieces together, when you see the full pattern, it's undeniable. We have an object that is losing more mass than it weighs without fragmenting, changed its rotation period by 41 minutes without visible cause, has a dark central core surrounded by a geometric ring, is dimming as it gets closer instead of brightening, has a tail that wobbles with mechanical precision, changed course at the exact moment of other anomalies, is heading toward Jupiter on an optimal gravity assist trajectory, has a tail pointing at the galactic center, shows regular pulses in its light curve every 144 minutes, might be receiving incoming signals. Each one of these, in isolation, could be explained away, could be attributed to unusual but natural processes, could be dismissed as an anomaly. But together, they form a pattern of behavior that looks suspiciously like control, like navigation, like purpose. I'm not saying this is an alien spacecraft. I'm not saying this is proof of extraterrestrial intelligence. What I'm saying is that the data is forcing us to ask questions we never thought we'd have to ask about a comet. Is this object responding to its environment? Is it making adjustments? Is it under some form of control? And if the answer to any of those questions is yes, then what does that mean? It means we're not alone. It means there are others out there, others who build things, others who send probes across the galaxy, others who are watching us. and it means that 3i Atlas isn't just a visitor. It's a scout, a probe, a messenger, and the message it's sending is, we found them. We have less than 3 months until the Jupiter encounter, less than 3 months to gather as much data as possible, less than 3 months to figure out what this object actually is. Every major observatory on Earth will be watching. Every telescope that can point at Jupiter will be tracking 3i Atlas as it makes its closest approach. We'll be measuring its trajectory with unprecedented precision. We'll be monitoring for any deviations from gravitational predictions. We'll be watching for any response to Jupiter's magnetic field. And if there's any course correction, any anomaly, any indication that this object is doing something beyond pure gravitational physics, we'll see it. This is the test. This is the moment of truth. March 16th, 2026. Mark your calendars, because that's the day we'll know for certain. Either 3i Atlas is the strangest natural comet in history, an object that breaks every rule we thought we understood about how comets work, but is still ultimately just a rock and ice. Or it's something else. Something that's been traveling through the galaxy for millions of years. Something that's been sent to explore. Something that's reporting back. And if it's the latter, if this object really is under some form of control, then the Jupiter encounter isn't just a scientific observation. It's first contact, not with beings, not with a civilization, but with their technology, with their probe, with their eyes and ears in our solar system. And they'll be watching us just as closely as we're watching them. Now let me tell you what's happening behind the scenes. What the official channels aren't saying. There are astronomers who are privately admitting that they don't know what to make of this object. There are scientists who are running models that keep coming back with impossible results. There are people in positions of authority who are asking questions they never thought they'd have to ask. And there's a reason you're not hearing about this on the evening news. Because if they admit that 3i Atlas might be something other than a natural comet, if they acknowledge that the data is pointing towards something artificial, something controlled, something sent by an intelligence from beyond our solar system, then they have to answer the next question. What do we do about it? Do we try to communicate with it? Do we send a signal? Do we attempt to make contact? Or do we stay silent? Do we observe from a distance? Do we hope it doesn't notice us? These are questions that humanity isn't ready to answer. These are decisions that no single government, no single organization, no single person has the authority to make. So instead, they're staying quiet. They're releasing the data in technical papers that most people won't read. They're talking about unusual comet behavior and anomalous observations without ever saying what they really think. They're waiting, watching, hoping that the Jupiter encounter will give them definitive proof one way or the other. But here's the thing. We don't have to wait for official confirmation. We can look at the data ourselves. We can see the pattern. We can draw our own conclusions. And the conclusion is clear. 3i Atlas is not behaving like a natural object. It's behaving like something that's under control, something that's navigating, something that's on a mission. And in less than 3 months, we'll know for certain. 3i Atlas is changing course. It's heading toward Jupiter, and it's doing things that should be impossible. It's losing more mass than it weighs. It's spinning faster without visible cause. It's maintaining a geometric structure that defies physics. It's dimming when it should be brightening. It's wobbling its tail with mechanical precision, and it's pointing that tail directly at the galactic center, transmitting data back to wherever it came from. Every anomaly is connected, every behavior is coordinated, every action is happening at the exact right moment. This is not random, this is not chance, this is a pattern, and patterns imply design. Design implies purpose. Purpose implies intelligence. I'm not saying this is definitely an alien probe. I'm not saying we have proof of extraterrestrial technology. What I'm saying is that the data is forcing us to consider possibilities we never thought we'd have to consider. The observations are pushing us toward conclusions that sound like science fiction, but are based on hard science. And in less than 3 months, on March 16th, 2026, we'll have our answer. Either 3i Atlas will pass Jupiter following pure gravitational physics, proving it's just the strangest natural comet we've ever seen. Or it will deviate, it will course correct. It will respond to Jupiter's magnetic field in ways that gravity alone cannot explain. And if that happens, if we see that deviation, then we'll know. We'll know that we're not alone. We'll know that there are others out there. We'll know that they've been watching us, and we'll know that 3i Atlas was sent to find us. The countdown has begun. 3 months until the moment of truth. 3 months until we know what this object actually is. Stay vigilant. Keep watching, because what happens next will change everything. If this information resonated with you, if you see the pattern I'm seeing, let me know in the comments. What do you think 3I Atlas actually is? Natural comet or something else? And if you want to stay updated on every development, every new piece of data, every anomaly that emerges in the next 3 months, subscribe, because I'll be covering this story until we have answers. The universe is stranger than we imagined, and 3I Atlas is proving it. Thank you for watching, and keep looking up, because they might be looking back.